Hi there. So in this video, we're going to keep going with Bootstrap confidence intervals, but I'm going to show you another way to get a 95% Bootstrap confidence interval. It's a tongue twister. And also with this method, we can expand this to different confidence levels. Okay, so we're going to try 90%, 99%. And with the app we were just using, it's really quick and easy. It's really just reading off the graph. It's generating the Bootstrap distribution and reading off the graph, okay? So let me go back to where we were in the last video. We had just generated for the Mustang prices. We had our one original sample, which is the same sample every time you go to this app. It's just this one sample. And then the Bootstrap, we made our Bootstrap distribution, right? And we used plus or minus 2 times the standard error to get our confidence level, or confidence interval. Okay, now another way, remember how we said in the normal distribution, you go out 2 standard deviations or 2 standard errors to capture the middle 95%, right? So that's using a theoretical model that's based on that sort of perfect normal curve. Well, we can do a similar thing with our Bootstrap distribution here, because the computer can actually count where are the middle 95% of all the dots. Okay, so that's what it's going to do. If we click on two-tail right here, and that's because we want 95% in the middle, which will leave, it's basically cutting off the extreme values. We're saying we don't want the extreme, we just want to capture the middle 95% of all of our estimates, our random samples. So by clicking two-tail, the default option is 95%. So this corresponds to our confidence level. This is the percentage of dots, 95% of our samples were between these two values. And let me move this up just a little bit to make sure you can see that. We're going to look at the values at the bottom, okay? These are the price values because the price scale is along the horizontal axis. The numbers in the middle correspond to areas or percentages. So you could think of, if this was a nice curve, we could think of the area under the curve as 95%, or 95% of all of the samples we took, 95% of all the dots here. And then if we take the rest of that 5% is left over, there's half of that is on the left tail and half of that is on the right tail. So that's why you see 2.5% or 0.025 in the right tail and 0.025 in the left tail. Okay, so essentially what this says is we want to generate our Bootstrap distribution and then take the values that capture the middle 95%, okay? And that would be 11.964 thousand and 20.328 thousand. Okay, so I'm going to write that down. That's our confidence interval. Can you believe it? So I'm going to write it down before I go away from the app, and then I'll show you the notes. So I'm actually going to just write down, I'm going to put it in dollars, 11,964, comma, 20,328. Okay, so I wrote that down. Let's compare that with what we got before. And see, it won't be exact, right? Because we will never get the exact same thing. But it's not too far. If I compare my dollar value, 11,734, 11,964, up to 20,226 or 20,328. So it's around $100, $150 off, okay? So, but pretty close, same idea, okay? And then in the notes on this notes page, I have a picture of that. And I've got space on this one, so I might write out the interpretation. But I wanted to put a screenshot in the notes. And again, this is from a previous simulation, so these numbers will be slightly different as well. So I'm going to circle the ones you're going to use. This is our confidence interval. down on the horizontal scale. And then the one in the middle is our confidence level. Okay, we have the same standard error, so that's another way of doing it, is going out 2 standard errors, which should be, if this is approximately normally distributed, then it should look similar, okay? And then also just to remind you how we got, if you're curious about these are called percentiles. 2.5, the 2.5 percentile or 2.5 percentile means there's 2.5% to the left of this value right here. Okay, so if I do 1 minus 0.95, that's 0.05. So if I take away, 95%, I have 5% left over, and then we're dividing it in half because we have 2 tails. So 0.05 divided by 2 equals 0.025 for each tail. Okay, later you might want to adjust these tail numbers, I'm not sure, but most of the time what we're going to adjust is this confidence level, okay? Okay, great. Okay, so I promised I would go back and write out the interpretation because I think it's important to keep doing that. So, and I haven't done it for bootstrapping yet. So it's the same interpretation we were doing before. We are 95% confident that the interval from $11,964 to $20,328 captures the true mean Mustang price. Okay, and remember there's many different ways to write it, as long as you get true mean or population mean, or all price of, average price of all the Mustang cars, and then your confidence level. Okay, great. So I mentioned we could do different confidence levels, so let's go ahead and do that. We can get any confidence level we want using our Bootstrap simulation or Bootstrap distribution. Okay, so the only thing we do want to double check is that 2 tail box is checked, and you can double check that visually by seeing that there are 2 tails, and they're marked with X's on, and they're also red in the actual app, but my printout is black and white here. So let's find a 90% confidence interval using percentiles. Okay, so now I'm going to click on this box that has the level in it and type 0.90 and either enter or hit OK. And notice what changed. So now I have 0.9 or 90% in the middle. So think about what's on the edges. That's 10% left over, so cut that in half. That's 5% on each side. And notice it doesn't seem as wide, right? Because we're only getting the middle 90% rather than the middle 95%. So we've come in a little bit, but we're only 90% confident. Okay, so let me write this down. We have 12,556 up to 19,564. Okay. And remember, let's say you were starting this problem from scratch, and you might just have to generate your whole distribution. So let me show you that. So let's say you were starting, this is a brand new question in MyOpenMath or wherever it is. You would come to this app, select mean select Mustang price. If you want, you can go right to the 2000 once you feel comfortable. Then you're going to click on two-tail, boom, and then type in whatever your confidence level is, okay? So I got a slightly different values, of course, right? So my Open Math knows that. It's programmed in. But of course, if it's not accepting your answers, let me know. So this time I got 12,602 to 19,724. Okay, so I'm going to write that one down. 12,602 up to 19,724. Okay. Okay, so these are from two different simulations. Okay, so we are expected to get different answers. So answers will vary. They're always varying around that same initial X bar, right? That's not changing. Okay, so let's do another. Sorry, I'm trying to figure out where my paper is. Let's do another confidence level. Okay, so I have in the notes, I have the image for 90 that we just did. Put that image in there for you. And if you want, just mark some notes on there. We changed this to 90%, 0.90 for that, and then we read off our confidence values there. Okay, so this is one where an assignment might ask for a screenshot, a screen capture, since there isn't really any other work to show. With the standard error, you can show plus or minus 2 standard errors, but there isn't really much to show for this other than this picture. Okay, let's do it again with 99% confidence. Okay, so I'll stick with the distribution I've got right now. Click on the middle number and type in 0.99. Okay, now you notice we're getting a wider interval, right? Because we're doing the middle 99%. And what's on the sides? There would be only 1% left over. So this would be half of 1% or 0.5% in the tails. Okay, so the idea is we're going to cut off those very extreme values and go with our middle 99% or 90 or 95. Okay, so our 99% confidence interval is $10,940 to $22,240. Okay, go back, put that in the notes for you. And then I have the screenshot for this one as well. 0.99 for 99%. And then we used our two values right there. Okay, great. So if you haven't, you've probably likely done this at some point already in this term, but just in case you haven't, you'll use a snipping tool or a screenshot if you're guided to, show your work for this type of question, show an image from your simulation. So in Windows, I use the snipping tool, and it's, let's see if I can show you. That's the result of it, but it looks like this little scissors, and when you hit new, then it lets you select an area. Okay, so I would select that, just making sure I have all the values. I might want to do a little better job of making sure I have all my scale and everything like that, or the whole thing. That's my snipping tool. Or on a Mac, if you do Command-Shift-4, then you'll get the crosshairs again, and you can select the rectangle that you want to select. Okay, Great, so that was all for means. So let's do it again in the next video, but with a proportion. Okay, see you there.